Hi, everyone. Thank you so much for taking the time to watch the project video for the Tech and Check Bass Connections team. We are a collaborative effort between Duke, UT Arlington, and Google Research aiming to develop an automated fact-checking system that uses data and computing power to make sustainable and effective fact-checking systems for the public. Through the development of this platform, we hope to develop a pop-up fact-checking service that allows users to know the factuality of statements without having to do the research themselves. The need for this project stems from fact checkers being overwhelmed by the number of claims made in the news each day. However, developing an automated system to create fact checks is a bit complicated. In order to assure that a claim is correctly identified as true or false, they need to be reviewed by a fact checker. Their work generates fact checks, which we then store in a database. And the automation comes in when these claims are repeated. As claims are restated frequently, repeated claims can be compared with a database of fact checks to determine whether they are true or false.
The first step is transforming speech to text correctly. This step, we use Google Cloud Speech to Text to transcribe audio to text. Compared to alternatives that we tested such as DeepSpeech, which is Mozilla's speech-to-text service, and Gentle, Google Cloud Speech to Text had the most accurate transcriptions. Step 2 is determining what to check. This is a crucial step because most of the statements are not checkable or worth checking. So to identify checkworthy claims, we use ClaimBuster, an algorithm developed by computer scientists at the University of Texas, Arlington, and it scores each statement based on its potential checkability, not its accuracy. In related efforts, we also use ClaimBuster for Tech and Check Alerts, which is a daily newsletter for fact checkers across America that provides a list of filtered claims that we suggest as checkworthy. There's a national newsletter that contains claims scraped from CNN and Twitter, as well as a North Carolina-specific version that includes claims from Twitter. We've also used Google Cloud Speech to Text to transcribe political television ads, and then use ClaimBuster to identify the most checkworthy statements from those advertisements.
Once the checkworthy claims have been identified, we match them one by one to fact checks from our database, which we have compiled on an ongoing basis from a number of reputable fact-checking organizations. To do this, we've developed a variety of approaches. One uses a search engine called Solr to find relevant matches in the database. These can either be the final result, or we can improve upon them with some of our more complex algorithms. Another approach that some members of the team have worked on recently is to first classify each claim into one of a few possible semantic categories in the hopes of improving the relevance of the matches.
In order to improve the accuracy of our matching algorithms based on supervised machine learning, we need a lot of training data. We thus developed a process and software infrastructure for collaborative data labeling. Automated scripts will generate claims and potential matches and then divvy them up amongst members of our Bass Connections team for manual verification. Our scripts will also monitor progress, consolidate the results, reconcile differences in individual data labels, and then produce a final integrated label data set, which we can then use to evaluate and train algorithms.
Our expert curation page allows journalists to view incoming claims and manually select matches before they are presented to the end user. When opening a claim, the journalist is presented with the most relevant fact checks taken from the automated pipeline and can select one to be displayed to the end user. Multiple users can work concurrently, with in-review and selected claims being represented by gray and green backgrounds respectively. This process only takes a few seconds for the journalist, but tremendously increases the accuracy of our results.
The UX team focuses on researching how people consume media. This year, we've conducted surveys on different delivery methods, such as TV versus mobile, as well as interviews on what is the most important information to the user, such as source or dates. Finally, we've designed and tested different layouts for web delivery, as well as forms of onboarding to make sure the user really understands what they're seeing.
The challenge we tackled this year is that users may experience a live event with different delays or even at different times, but we still want the related fact checks to be shown at the appropriate times, not ahead or significantly after the claims were spoken. To this end, we created a mobile application for both iOS and Android using React Native. The app listens to whatever the user is listening to through the mobile phone's mic. After the algorithm finds a match, it displays the name of the event along with a timestamp.
Last but not least, as part of this Bass Connections project, we also wanted to look at how fact-checking can help combat misinformation in more specific domains. Vaccine hesitancy was named one of the top 10 global health threats by the WHO in 2019. However, there's still no personalized intervention to combat vaccine hesitancy. One challenge here is that it is difficult to pick up vaccine myths from individual sentences, and sentence-by-sentence rebuttal may not work well here. To address this challenge, we built a taxonomy for vaccine misinformation, as seen here, which serves as a knowledge hierarchy of common anti anti-vaccination tropes. Our taxonomy is broken down into 5 key categories. We can then label anti-vaccination articles into categories in our taxonomy, which helps with coming up with appropriate intervention articles. We tried 3 different approaches to labeling: basic counting, weighted by TF-IDF, and word embeddings. We then developed a survey that asked participants to label paragraphs into categories in our taxonomy so that we could gather a large data set for training models.
And that sums up the presentation for our project. Thank you so much for listening, and remember, one fact check a day keeps the fake news away.